Welcome back. In the last section, we started to look at how to use loops to get repeating behavior from the computer. And the kind of loop that we looked at was called the for loop. The for loop is interesting because it's very useful in a very specific application. That is, we know the number of times that we want to do something. And if you remember, the for loop had three pieces. It had first a century variable, the thing that we were interested in, and then it had the ability to initialize that variable, and then the ability to test that variable against some condition, and then finally the ability to modify that variable. Well, that's all very good, but it's very specific to a particular kind of issue, and that is, okay, I know something is going to happen 10 times. I'm going to do something once for each element in a list or something. And that's great. That happens a lot. But there are other times in programming where we want repetition to happen, but we don't know how many times it will happen. And passwords are a great example. You've all done passwords, right? And so you have this password situation where you have to enter a password, and it will keep going until you get the password correct. So if you get the password correct on the first time, you're out. And everything's good, but if you get the password wrong, it keeps going until you get it right. Yes? Okay. And so let's take a look at a simple version of that. Here's the guess the password. Of course, it's not difficult. I sort of gave it to you. I know. Isn't that the best kind of test ever? All right, so here we click on the guess password, and it says, what is the password? Well, let's see, XHTML. No, that's not it. CSS? No. I have no idea. No, that's not it. Eventually, I'll say HTML5, and it says, you may proceed. No, it never says it like that. I have to have a robot voice. You may proceed. All right, so, okay, good. We did this, right? We were able to get through it. The thing about this, clearly it's a looping behavior, right? We got looping happening, no doubt about that. The question is, how many times do we loop? Well, it's indeterminate. It's not like a for loop where you know exactly how many times it's going to happen. This kind of loop is a little more flexible because we don't know how many times it happens. It happens as many times as necessary based on some sort of circumstances. Okay, I can follow you with that. All right, so what are we going to do? Well, let's look at the code. As usual, we'll use our, Control U. And the HTML is very, very simple. It's a form with two buttons. Each button has an on click. Okay, got that. We're going to only worry about this first one for now, the get password. So let's take a look at get password. That's this function right here, and get a sense what's going on. It's actually not super surprising. The first thing that happens is we have a variable. Now, I call my first variable correct, and my second variable guess. Now, this is really interesting because a lot of beginning programmers will call one or both of these variables password, right? Because they're passwords. But here's the thing. We've got two potential passwords. One password is the one that we're trying to guess. It's the actual real password. The other one is what the user thinks is the password. Both are password. So do you see how confusing it could be if you have two different things that are called a variation of password? A beginner might call this password and real password, or password 1 and password 2, or ACK. Okay, I'm going to be very careful how I name things. I'm going to call the correct answer correct, and I'm going to call the one coming from the user guess. So far, so good? Okay, now I'm also going to initialize them. Typically, when you create variables, you like to give them a good, solid initial value. So the initial value of correct is going to be HTML5, my not-so-secret password. Okay, great. Now, the guess coming in from the user, I'm going to initialize that too, but what am I initializing it to? I hear you loud and clear. Nothing. Thank you for saying nothing. That was the right answer. So var guess gets nothing. So the initial guess is an empty string. Okay, you follow me? You follow me. Okay. Now take a look at line 13. We have this statement, while. Now once again, you've seen while used in English, right? Okay, well, I'm hungry. I'm going to take another bite of cereal. And that I'm hungry condition is true. Okay, before I get up in the morning, I get up, I come downstairs, I pour my milk and cereal. And am I hungry? Yes, I'm hungry. That condition is true, so I eat some cereal. You should see me. I'm actually doing a little eating motion here off camera. So I can eat some cereal. I have a bite. Am I still hungry? Yes, I'm still hungry. Condition is still true. Have another spoonful. Eventually, I ask myself, am I hungry? And the answer is, no, I'm not hungry. I've had plenty. Thank you. And what do? We put the bowl down. That's what we're supposed to do. I know. My diet plan doesn't work that way. But that's our plan, right? I mean, when we're done hungry, when I am hungry is no longer true, we get out of the loop. Okay. That's the basic idea of a while loop. The while loop appears to have only one part, a condition. And as long as the condition is true, we stay in the loop. As soon as the condition is evaluated to false, we get out of the loop. Does that make sense? Okay, watch. Here's the condition. Guess is not equal to correct. Now, a lot of times in while loops, conditions will be expressed as some sort of a negative. I hope that doesn't bother you. It's just the way it is. The while loop, the way it works is, if the condition is true, we stay in the loop. If the condition is false, we get out. So what condition causes us to stay in the loop? Guess is not equal to correct. Okay, you following me? Okay, so as long as this expression, guess is not equal to correct, is true, we stay in the loop. Now, on our first pass, correct is HTML5, guess is nothing. Is HTML5, or is nothing, equal to HTML5? Or is nothing not equal to HTML5? Yes, nothing is not equal to HTML5. I know, it's a little awkward. But that condition is true. And so what do? We do all of the code in between the squiggle brace and the corresponding end squiggle brace. Like with our other structures we've been seeing, you can have as many lines of code in here as you want, and we're going to do that, okay? So now inside here, I say, all right, guess gets prompt password. So inside the loop, I have whatever code I want, but one of the things I'm going to do in the loop is try to get a new guess, which is logical, isn't it? So we're going to ask for a new guess, and so hopefully it will be possible. You know, we get to the end of the loop, it pops back up here and checks the condition again. Okay, this time is guess not equal to correct? Okay, so if they're the same, the condition is false, we get out of the loop, we can proceed. If they're still different, the condition is true, we stay in the loop. And you keep on doing this. Does that make sense? Yeah, while loops are actually a little bit simpler than for loops on the surface because they seem to have only one part. They just have that condition. So as long as the condition is true, we stay in the loop. As soon as the condition becomes false, we get out of the loop. You following me? Okay, now that you agree with me, I'm going to tell you that's not true. While loops, sure, the syntax of the while loop only requires one thing. It only requires a condition. But the proper operation of a while loop actually requires three things. You have to have a sentry of some sort, and that sentry must be initialized. That sentry must be in a condition, and that sentry must somehow be changed. Wait a minute. You've heard this before, haven't you? Remember the for loop? We said in a for loop that you have a sentry, you have to initialize the sentry, you have to test the sentry, and you have to change the sentry. How's it start? How's it end? How's it change? Those are the three things you think about in a for loop, right? What are the three things you think about in a while loop? Okay, four things. What's my sentry? How's it start? How's it end? How's it change? Same thing. You think about the same thing in a while loop that you do a for loop. It's just not built into the syntax of the while loop. So when you build a while loop, you still have to think about what is my sentry? How does it start? What's the initial value of it? How does it change? What's the condition? That's pretty obvious. That allows us to continue the loop or get out. And finally, how does it change? So what happens in the code to ensure that the sentry will change, triggering the condition to eventually become false so we can get out? Make sense? This is the tricky thing about while loops. While loops cause people a lot of trouble because it's not so obvious exactly what you need to do, and because some of the things you need to do aren't on the same line. So, for example, with this while loop, we have this guess is not equal to correct, but what that means is we have to have both of these variables already defined, and we have to be reasonably confident that they're different before the first time we get here, and that they can change so they can eventually become the same. Does that make sense? Okay. So what's my century? This is a little tricky because I've got two variables here. But which one is the century? Well, the one that changes. That would be guess. You follow? Okay. So there's my century guess. Now, it has to be initialized, but here's the tricky thing about a while loop. You initialize before you get to the while loop, not in it. In a for loop, you could initialize right there, but in a while loop, you have to initialize before you get there. And you have to put some thought into the initialization to ensure that the condition is true the first time. Usually, occasionally you'll design a loop that doesn't even happen the first time, but usually you design your loop so it happens at least the first time. Okay, that makes sense. Now the condition is obvious because that's built into the syntax of the while statement, but the change is not so obvious. That needs to go inside the loop. So inside the loop I must have some line of code that changes my century in a way that guarantees eventually the condition will be true and eventually I'll be able to get out of the loop. Does that make sense? Yeah, that makes sense. And that's the tricky thing about while loops. They're very easy syntax to build, but they're also very easy to mess up and cause you problems. And so we want to be really, really careful. What could go wrong? Well, let's see. What if I put this line 14 after the while loop? Well, we'd never get there. What if I started out correct and guess both with HTML5? Yeah, we would exit the loop immediately. Two things that can go wrong in a loop is it never happens. It's recalcitrant. Oh, look that up. Unless you're an English major, then you should just feel proud of yourself. Or it's endless. It never stops. These are the two things that go wrong a lot of times with while loops. And in the context of a web browser, this can be really nasty. A loop that goes on forever can turn out to cause you big problems. You may have to shut down the whole browser to get control back. Ugh. Yeah, I know, it's a pain. Alright, so we want to avoid bad-tempered loops. We want them to act properly, and the key to that is, what's my century? How does it start? How does it end? How does it change? Make sense? One more thing I want to talk about. Look at this condition. Well, guess is not equal to correct. Is that a thing of beauty or what? Okay, I don't like to brag, but look at that. I love that condition. And why do I love it? Well, because I just about can't write a comment to make it more clear what's going on. So you pick your variable names. A very experienced programmer will pick variable names so that the code is self-documenting. I think about my variables by thinking first about the conditions in which I will use the variables. So it's really clear to me what I'm trying to do. As long as the guess is not equal to correct, we're going. If you look at your condition and it's not obvious exactly what it does, what causes it to start and stop, then maybe you should rethink your variable names. Yeah, that's a good idea, isn't it? Okay. So you follow me? Yeah. So the while loop, very, very powerful. Okay. So that's pretty good. That's pretty good. Can I show you a variation? Okay. Here's an interesting variation that you'll sometimes see. And that is this. So I'm going to ask, so I'm going to do the password, and if I get it right the first time, we're out. Okay, that's good. But a lot of times in passwords, we don't want people to be allowed to do it forever because then they could write some sort of a bot that would just randomly go through a dictionary and pick things. So one easy way to defeat that is to say, well, if you get it wrong 3 times, it says, too many tries, launching the missiles. So watch out, there's missiles coming. Okay, and then we get out. So how do we get out of this loop? Well, there's 2 different ways, right? It goes until 3 times, so that must be a for loop. No, that's not exactly right. It goes until we get the password correct. Well, that's not exactly right either. It goes until either we get the password correct or we do it 3 times. Now, this kind of situation comes up all the time, and there are a lot of different ways to resolve it. Now, I'm going to give you one specific solution to it that I'm going to heavily encourage you to use because it works very well. Let's go ahead and look at the code again, and I'll show you what we're talking about here. Now, this 3 tries. Take a look at what I'm doing. I've got correct as HTML5, and I've got guess as empty. I've got a third variable called keep going. Now, keep going is a special variable. It's called a Boolean variable. It can only be true or false. Okay, that's interesting. And then there's a fourth variable, tries, that keeps track of how many tries we've done. So far, so good? Okay, now watch what we're doing. Now, some of you have been aware of stuff like Boolean logic, where you might try to do an AND statement. You know, while guess is not equal to correct and tries is less than or equal to 3. Okay, that's a legitimate way to do it. Please don't. It turns out that causes you nightmare after nightmare after nightmare. If you do it the way I'm about to tell you, your code can be as complex as you want, and you will be able to manage it. I am not a fan of beginners using Boolean operators like AND, OR, and NOT in conditions. I just think it's going to cause you trouble. This gives you the same behavior, but it's much easier to follow. You with me? No, you're not. Okay, but that's okay. Follow along. See what happens. So while keep going. Now, this is interesting. In our conditions, normally we've done a comparison. But the key thing about a condition is not that it's a comparison, but that it's a Boolean. It's true or false. Well, keep going. It's true. So, okay, great. We can use a Boolean variable as a condition. And it has certain charm. So, while keep going. Well, is keep going true? Yep, sure is. All right, let's see what happens. Guess gets prompt password. So, ask the user for a password. They type something in. Now, if guess is equal to correct, then we tell them, okay, super, you can go on. But then we do something else neat. See, keep going's whole job is to be a sentry. It doesn't do anything else. The problem with guess as a sentry or tries as a sentry is that being a sentry is their second job. Their main job is to be a guess or to count the number of tries. Well, as soon as your logic gets complicated, I'm a big fan of having a sentry whose whole job is to be a sentry. It's a Boolean, that's simpler, and if you have lots of exit conditions, well, you can separate the logic of what the various variables are doing from the loop logic, and it's a really good idea. So line 32, what it says is, keep going is false. Next time I get to this thing, we're done. Clever, huh? Okay, so if guess is equal to correct, we're going to tell them they can proceed, and we'll set keep going to false. We skip the else clause, come back here, keep going is false, we're out. Everything's good. Now let's say that they type in the password and guess is not equal to correct. Okay, we drop down to this else clause. Increment the number of tries. Now we have another simplistic condition sitting on its own, so it's very easy to think about. If tries is greater than equal to 3, so they've tried too many times, right? If tries is greater than equal to 3, then we tell them too many tries, launching the missiles. Once again, we set keep going to false, meaning next time we get to this condition, we're out of the loop. You see how clever this is? So let's say that they get it wrong, but it's their first try, right? So guess is correct. No, their guess is not correct. Tries is currently 0. Now we'll make it 1. Okay. Do we leave the loop? No, we stay in the loop. They guess wrong again. Tries is now 2. Do we get out of the loop? Do we tell them we're launching the missiles? No, we keep going. Tries is now 3. Too many tries, launching the missiles. Keep going is false. We get out of the loop. You see how powerful this is? This one particular strategy, and that is the moment you find your loops getting complicated, as they very much will in games, you separate out your sentry and make it a Boolean. Simplifies your life in so many ways. I wish somebody had taught me that. Almost all of my loops use a Boolean these days. Almost all of my while loops use a Boolean because it simplifies my programming so tremendously. And I'm going to strongly encourage you to use this. And as you look at the other examples, as we start making complicated games, this is very much a way that we'll do things. So we'll tend to use this kind of a Boolean loop so that even if there's multiple exit conditions, we're going to be okay. And in gaming, that always happens, right? I can hit the quit screen. Maybe the game ends when I run out of lives. Maybe I reach a maximum score. Maybe I defeat a boss. There could be lots of different ways that we get out of a loop. And this kind of approach allows us to have a lot more flexibility in our loops. Use this and you're likely to have fewer problems with your loops, and looping problems are by far one of the biggest issues that beginners face. Okay, I'm going to show you one more cool thing about how to fix and detect errors. See, the sorts of errors that we run into now with looping are not necessarily syntax errors where the whole thing crashes, but they're logic errors where all the code is technically correct, but what you're telling to the computer to do doesn't make sense. And so those are much trickier to find. Here is a program. Okay, guess the password. You may wait a minute. Hold on. I can proceed. That's the easiest password game I've ever done. It never even gave me a chance to type it in. Huh? Okay, we can look at the source code, and it looks perfectly okay. Correct, guess. Well, guess is equal to correct. Guess gets prompt of password, and you may proceed. Looking at that, nothing wrong, didn't complain, but it doesn't run correctly, does it? Clearly, it's not running correctly. How can we figure out what's wrong? If only we could peek into the computer's brain. If only we could stop the program and run it in super slow motion and look at what's happening in real time. That would be awesome, wouldn't it? Well, this is one of the reasons that I'm encouraging you to do your programming in Chrome, because it has some marvelous tools for debugging. I'm going to show you really quick how we can look at these things. The F12 key brings up the debugging console, and it's a marvelous, marvelous set of tools. Typically, when you're running JavaScript code, it'll pop up already in the sources window. If it doesn't, that's what you'll want to find. Now, in this case, I've already been using this, but here's what I'm going to do. I can see the code right now, and there's a bunch of scary things going on there. But I look at the code, and if I click on one of the line numbers, what that means is, okay, next time this thing runs, I want you to stop right there. So let's reload. That's how we'll run the code. And then we'll hit the guess the password button. And you can see it stopped. It highlighted this. It says paused in debugger. So what happens is the highlighted line is the one that's about to happen. And if you look, we can see a list of our variables. Anytime you're not sure what's going on in computer memory, you typically want to look at the variables and see what their current values are. Okay, so correct is undefined, guess is undefined. That's because this line hasn't happened yet. Now we can use this button or this button. At the moment, they mean the same thing, to move on to the next line. Now we're about to run line 11 and take a look. Correct's value is HTML5. Okay, I get that. Now we go to the next line. Whoa! We instantly shot down. Another neat thing is we could just highlight over these things and we can see their values. And that could be really useful because we say, hey, guess is empty, correct is HTML5. Well, guess is equal to correct. Well, that's not true, so we got out of the loop. Oh, what did I do wrong? This is the wrong condition. I should have said, well, guess is not equal to correct. And do you see that? It's subtle, but it's important. A lot of times we get our head turned into knots, but when we can use a tool like this debugger, then we can look at the variables in memory and we can look at what's going on. In fact, we could even add an expression. We could say guess is equal to correct, and it'll tell us whether that's true or false. That's kind of neat, right? Usually I can tell. I just look at it. Okay, so if we ran it again, that'd be great. Now what's happening here? Well, that should have been not equal. So what happens is, of course, guess is equal to correct is false, so we never get to the part where we get to prompt and ask a new password. The code is there, it just never happens. Oh boy. Okay, once you can see it, you can fix it. And that's what a debugger is for. Does this make sense? Yes, it makes sense. Okay, so we've come a long way. We're learning a lot about programming. You really need to practice this like so much else. So make sure you practice this. You write some code that has some loops that work with user input, because we'll use this quite a bit in our gaming. Next time we're coming back and we're looking at some interesting ways to organize our code for even more power and flexibility. I'll see you then.